Welcome to lecture 5. In this lecture we are going to be download KEIL software and how to install it and what is the difference between assembly and C language programming. Let's go and download the KEIL software. Just you go for Google browser, just type www.keil.com. Once you click this one, it goes to the KEIL home page. Here you can click product downloads. Here you see C51. It is a development tool for all 8051 devices. Just click this one. Before you are seeing this file, before that ask your personal details. What is your first name, last name, your mail ID, your mobile number, which country you are belongs to, and ask the terms and condition and just click OK. You will get this page. Here you having C51v960a.exe file. It's just 96 MB. It will take a few minutes to download. I have already downloaded. I save it in the C folder. You see C51v951.exe file. It is the application file. Just you double click. Just give yes and give next, and I agree to all the terms of the preceding license agreement. Just click this one and just give next, and destination folder it will ask. You can, as it is in the C folder, you just leave it and just click next, and just here enter your personal details from Kumar. Company name, my college name, it is Anish. Email ramu16renu@gmail.com. Okay, just click next. It will take few seconds to installation. It is an open source software. It will support all 8051 series, as well as it will support ARM microcontroller also. It is 32-bit microcontroller. Okay, once it's downloaded, just give finish and go to your desktop. You have in the KEIL New Vision 5. Now, how to work with this KEIL New Vision? Coming lecture and all, we are working with this KEIL New Vision software only. In this lecture, I will explain you how to write the program. Once you write the program, how to save. Okay, you will get this window like this: file, edit, view, project, flash, debug, peripherals, tools, so on. First you go for project. Here just select new vision project. It will ask you the folder. You just go for the desktop. You create a new folder like C programming. In that folder you can give a project name. test 1, save. It will ask the target device. Okay, we are going to be write the program for AT89C51, AT89C51. It will come over here and you will see in the lecture 4 whatever the future we discussed, those features and all reflect over here. It is a 24 megahertz. It is CMOS microcontroller, 32 input and output lines. Here it consists of two timer, two 16-bit timer, 6 interrupt sources and one serial port. We call it as a UART, and 4 kilobytes of flash memory and 28 bytes of on-chip RAM. Just click OK. Here just click no. Okay, here the target is selected under your project name test 1. Now we have to be write the program. There is a two option to what is that, select the new page here, or else you go for file and just give new. In this lecture I have to show demo on two programs. One is on C, another one is on assembly level programming. Just already written. For consuming my time, just I copy and paste over here. It is the include. These things are all I explain in the subsequent lecture. In this lecture I will demonstrate how to work with this KEIL software. I am just sending the values from 0 to 255 on the port 1. Okay, once you can write the program over here, you go for save. Okay, in the same folder, the desktop, you created the folder C programming. In that you give the project name as test1. Here I want to save test1 dot, what is the program we written using embedded C. That's why you have to give the extension .c and just give OK. Just see the colors gets changed. Now I have to be add this program under this target. So source group, just right click, add existing file to group 1. Here you see test1.c, just click it and add and close it. Now you can see under this project, okay, we selected the target AT89C51. Under that you have to be have a .c extension file. Now you go for the options for target. Here you have to be give the clock frequency. In this lecture, in this video lecture, in this lecture series we are going to be use 12 megahertz clock frequency. Here already it is 12. Just give 12 and output you have to be create the X file. Why? The microcontroller understand only the machine level code. That's why you have to be click this create X file. This file only you can what is that uploaded in the microcontroller and just give OK. Once complete this one, you go for translate. You convert the high level language program into the machine level program and build target files. This file is okay converted into X file and you have to be rebuild it. Now this X file is built into the AT89C51. Now I am going to be run this program. Just you go for start stop debug. Just click this one and click OK. And here you having your peripherals and go for IO ports. Here I am using the port 1. You see here P1 is a port 1. Now I going for what is the run button. This is a run button. Once you click this one, the entire program is going to be run. Suppose you want to see the line by line execution, you go for this step F11 or you can click this icon. Okay, the first P1 you have to be send the value 0. Initially z is equal to 0, that is moved into P1, so 0. The next 1, 2, 3, 4, 5 until 255. I am going to be run entire thing. You see they keep on transmitting the value. Okay, keep on transmitting the value. Just I'm going to be stop this one. Okay, I want to see the X file which is generated in the desktop. What is the name we created? C programming. Here you go for objects. Here you see the text file is generated. You just open it. Okay, this is your hexadecimal code.txt file. This file only is going to be uploaded in the 8051 microcontroller. Okay, that's all about the C program. Next, I am going to be write one assembly level program. You just again go for project, new project, again the same folder, desktop same folder, here C programming. Okay, if you want to change the folder like ASM programming, just click OK. It will ask the what is the target device 8089 C51. You just click it, okay, and just give no. Okay, the project name is selected in the desktop. Now I am going to be write the assembly level programming. The same concept. I want to transfer 0 to 255 on port 1. The same program I written in assembly. Just open the KEIL software and you have to be paste it. Okay. Here it's very tough. Tough in the sense who are new to this assembly level programming, you must know about all the instruction sets. Then only you can able to understand. Those who are already completed this assembly level instruction set, for them no issue. Anyway, in this lecture series, I focused only on the embedded C programming. No need to worry about it. I just want to give the essence. What is embedded C? What is assembly level programming? Okay, here there is no void, no header file, no curly braces, nothing. Just I written over here. Now again I go for save. So what the procedure I followed, the same only I am following. Okay, assembly level programming, the same ASM, for example capital A assembly. Okay, the extension .asm. Okay, what you have to be create the project name assembly level ASM programming, whatever the name you can give, no issue, and that file name also whatever you want you can give. Okay, here but extension is .asm. Just give ASM, you get color changed. Okay, now I want to be add this file under this target. So again source group, add existing file, and you go for desktop. I searching ASM file. You can scroll down. You having a assembly.asm. Just click add. Okay. Okay. In this project, okay, I chosen a target as 8089C51. Under that, I keep this assembly level programming. Now again you go for option. Again you have to be give 12 MHz frequency, and output you have to be create a text file and just click OK. Now you go for translate. Okay, then I go for build. Now it is converting assembly level programming into machine level programming, and you can rebuild. Now you can rebuild it. This program has to be fused into the microcontroller in this the KEIL compiler. Now again I go for evaluation mode, that is debug. Now again I go for the peripherals, the same port I'll take. This is a port 1. Okay, the same operation. Okay, now I am going to be stepwise. If you want to execute this one, it is going to be send the values from 00 to FF. Okay, here I am going to be stepwise operation. Okay, first 0, the next loop it is 1, the next loop it is 2. Okay, run it. Okay, continuously it is what is that 255. 5 is the maximum value we'll get. Okay, I'll close this one and come for this embedded C programming. Here, the second slide, you see the difference between these two. I write the program, I compile with the KEIL software. This is the machine executable code I will get. Okay, you convert that file, just go for desktop, C programming, and you go for objects. Here if you see the code, this is the hexadecimal code. Same it will generate for assembly level code also. I will check, I will show that also. Okay, here you go for objects. Okay, here asm programming.x, you see the file is x file is generated. Now come over here, you just see the difference. Okay, same program, the same concept. I am sending the values from 0 to 255 to port 1. Here also the same logic I applied. You just see the machine executable code. Okay, how many lines you see. But the same logic I written in assembly level programming. You just see the .x code. You compare to this one, it consumes more memory compared to assembly level programming. Okay, so the assembly level programming is good because it consumes very less program memory. You just see the comparison. Okay. Okay. The next C versus assembly level programming. What is the difference? You suppose you want to write the program in C. No need to study about the hardware details. Okay, how many? What is the register, instruction set, addressing mode? No need to study about the hardware details. And C is easier to modify and update. Suppose you are writing the program in the C, you little modification you do and you can use the same code for the other controller, but in case of assembly not possible. Why? The microcontroller to microcontroller, the architecture get varies, so you have to be thorough knowledge about the instruction set, assembly, what is that, addressing mode, then only you can able to write the code using assembly for that microcontroller. C is the most common embedded language, 85%. The embedded applications are coded in C because the daily 6 months once, 3 months once, the company are releasing the new microcontroller in the market. As a designer, they are unable to study the each microcontroller, instruction set, architecture, addressing mode, everything and all. Once they come to the market, immediately they start using the code with the help of embedded C. And C having some little some disadvantages. These are less control and ability to interact with the hardware. Okay, as given over here, you no need to study about the hardware details of microcontroller which you are using, because it is the compiler reliever programmer from the hardware details. But what is the disadvantage? You having a less control and ability to interact with hardware, that is a one disadvantage. And unclear number of cycle to do something. Suppose you want to generate some 5 millisecond delay, we can exactly create the delay with the help of assembly. Why? Because the assembly level programming, okay, for one, we know for one instruction how much time it will take to execute. With the help of that one, we can able to execute you can able to find out the time period. But in case of C, we doesn't know. For example, void main. Okay, how much time it will take to execute. So those things and all we are unable to know. That's why unclear number of cycles to do something. And C program is less time consuming, but it has larger X file. I showed in this previous one. What is the one disadvantage? It consumes more memory, but in assembly level programming, having a less memory. Okay, one advantage of assembly language programming is what is that? It consumes only the less memory space in the program memory, but other than that, the embedded C is a more advantage. Okay, you no need to know about much knowledge about the microcontroller. This is the difference between C and embedded C. Earlier it is C versus, that is embedded C versus assembly. This is C versus embedded C. Okay, this is a general C we are using for general purpose microprocessor, but it is used for the microcontroller based application. For writing C language, whichever you are studied in the first year BTech courses, the hardware knowledge is not required to write the C code. Okay, they talked about you just what are the data types. Okay, the printf, scanf, some header files, those things and all. They didn't teach about the hardware details. Here, the hardware knowledge is essential for embedded C programming. The little bit knowledge you must know. Okay, how many ports are there? What is the timer? Internal peripherals of 8051 like serial port? How many interrupts are there? Those the basic hardware knowledge is essential to write embedded C programming. Normal C is hardware independent. Okay, you can write the C programming as you wish. It is hardware independent. But embedded C is hardware dependent. You have to be know which controller you are going to be write the embedded C. So it is embedded C is hardware dependent. Suppose you are writing the code for Arduino, there the what is that, you have to write the different set of embedded C. Okay, suppose you want to write a 8051, there is a separate set of embedded C programming. C language OS dependent exe file. As in the starting of this lecture, I downloaded the file KEIL with .exe. Okay, that file is to be executed with OS dependent. But in case of embedded C, it will generate only the X file. Okay, if you want to run this as a C language, it must be an .exe file. In case of X file, to run in the 8051 microcontroller, .x file is sufficient. Always need an OS to run on a desktop, but in case of embedded C, we are not going to be use any OS, but you go for real-time application like high-end application. They are using the OS for the embedded system application. This is the structure of the C program. In this lecture series, we focused only on embedded C programming. So that's why first you have to be declare your header file. No need to worry about it. The next lecture I am going to be explain with some example how to declare the header file, how it will be look like this, and global declaration section. Suppose you want to write one main function, some sub function you can write above the void main, that is global declaration function and void main, and you can write the main program inside the infinite loop. Why it is infinite loop? Your program has to be run infinitely until you are going to be switch off the program. Okay, switch off the device. It is a declaration part. Okay, what is the variable, the character or float or the float or integer character, that one, and executable part. Okay, executable part. Inside the infinite loop there is a declaration part and executable. But executable means suppose I want to transfer 0 to 255 on the port 1, that line has to be included over here, and here user defined function. Already I told global declaration function, you have declared over here with the same name, you can use over here user defined function, and you can, okay, write the what is that, the separate program under this function. Okay, thank you.